beam of coherent monochromatic light from a distant galaxy is used in an optics experiment on Earth. The beam is incident normally on a double slit. What happens if it's not normal? I think it still works though. Anyway, the distance between the slits is point. Oh, there's a little hole in it here that you can't see. Is 0.300 millimeters. Okay, so that is our little d. In there's two formulas, right? S is lambda, the distance to the screen, d, right, divided by the distance separating the slits. We can also, if we want to do careful work, do n lambda is d sine theta. So that is the d, right? Okay. The screen is at a distance d from the slits. The diffraction angle theta is labeled. Okay. So this is the diffraction angle when they're talking about that, right? They're talking about this guy here. So we're going to get these Young's double slit. We're going to get these I'm so bad at this. So there's this overlying diffraction pattern, right? Okay, that we've witnessed, we've seen this, we've done labs about this, right? There's an overlying pattern, and then there's also the Young's double slit pattern that's going on here. Okay, a series of dark and bright fringes appears on the screen. Explain how a dark fringe is formed. So explain destructive interference. Explain the difference in path length. And that, remember, when it's destructive interference, it's a half wavelength difference. Okay, so just see if you can get those 3 marks. I think I managed to do it, you know. Okay, outline why the beam has to be coherent. Coherent means that these guys are in phase, okay? That when this thing's exerting, making a crest, this one also makes a crest. When this one makes a trough, that one also makes a trough. Obviously, if it's not coherent, if it's not in phase, if it's just at random phases, then you're just going to get a random addition of just random stuff on the screen. You won't get the beautiful interference pattern. Okay. The wavelength of the beam as observed on Earth is 633 nanometers. Okay. I think this is, we're going to use this guy, lambda d over d, right? Okay. I think I got this one. I didn't get me with this one. Notice that they're telling us the distance separation between a dark and bright fringe on the screen is 4.5. Okay, that means that this S is 2 times 4.5 times 10 to the minus third meters. So just be careful there. They like to do that, right? So they're not telling you this distance from here to here. They're telling you this distance, and you have to multiply by 2 to actually use this formula. So just be careful. It's an easy formula, so they're trying to make it harder for you. And then this is going to be your lambda, and this is going to be your little d, and you're solving for big D. Okay? I got something between 4 and 5 meters, I'm just going to say. Spoiler alert. Sorry about that. All right.